In this example, we are given some data that represent the square footage and rent for a number of apartments in a region, both a city and a county region. We're given the data here, and just whenever you go back to the problem statement, you'll see that we're only going to use the city data. Also given as the county data, but we'll worry about that later. We'll just delete it so we won't get confused by it. We're also shown a scatter diagram that shows the least squares regression line on top of the scatter plot. The problem is asking us to select the correct choice below and fill in the boxes as necessary, and each of these choices mention an outlier or influential point. So when I go back to the scatter plot, this is my first glimpse at what could possibly be an outlier. And I'm looking here for any point that is inconsistent with the general trend of the data. Something possibly with a large residual, large leverage, or both. So I notice here this particular point seems to be the furthest away from the regression line. Let's further analyze this inside of StatCrunch. So I'm going to open the data, open this in StatCrunch. Let's go ahead and delete the county data just because we don't need it for this particular problem. We'll go to Graph, Scatter Plot, select the X and Y variable, and then Compute. And we see here our scatter plot. Remember this point, if you click on it, it will actually highlight that particular point inside your spreadsheet of data. So I can quickly find that it's the point 460, 1805. Again, because it's inconsistent with the trend of the data, that's what is alerting me that this could be an outlier. All right, so now with that particular point in mind, let's do some further investigation to see if this point is also influential. So for a point to be, or an observation, to be influential, it must significantly affect the least squares regression line and or the correlation coefficient. So what we'll do is we will run a simple linear regression, including this point, and then we will run another simple linear regression after deleting this point. We'll then compare the least squares regression line and the correlation coefficient to see if there's any significant change. So let's go ahead and run that regression. So I have the point included here. We're going to go to Stat, Regression, Simple Linear, select X and Y, and compute. Here we see the least squares regression line. Notice this value is its slope, and this value is its y-intercept. And here we see the correlation coefficient. And if we'd like to see everything together on the graph, you can just advance one slide. I noticed that this particular graph doesn't look the same as the one that we were presented in my math lab originally, but that's due to the setup on the X and Y axis. If you wanted to go through and change that, you could select this menu feature down here in the bottom corner. You could go to X axis, for instance, and you could say, I want this graph to start at 0. Let's say, I'll just show you what that looks like when you change it. That's not necessary. But I can still see that observation is the furthest away from the line than any other observation. So all I've done here is taken a screenshot of that information that StatCrunch gave me, highlighting the y-intercept, the slope, and the correlation coefficient. Next, what we want to do is come back to StatCrunch, and we want to delete that one observation. And let's go back to Stat, Regression, simple linear. We'll select X and Y and compute. All right, so now we're looking at a new least squares regression line. Notice that the sample size is reduced by 1. It's now 11. And a new correlation coefficient. We can also view the scatter plot. Notice now it doesn't appear that as that distinct point that was so far away from the line isn't present anymore because we've deleted that observation. But I'm going to grab a screenshot of this information so that we can compare to see if the point that we deleted influences the least squares regression line and correlation coefficient in a significant way. So now just comparing the information StatCrunch gave us with the observation and without that observation, we look at, let's say the y-intercept to start with. It goes from -34 approximately to -399. That is a significant change. The slope changes from 2.2 to 2.5. That's maybe not as significant of a change, but based off of the y-intercept alone, we see that this particular observation was influential. It did change the overall linear regression line. We also see a change in the correlation coefficient. It went from 0.91 to about 0.97, so that's a significant change. So when we return back to our choices, we first identified this point as an outlier because it did not follow the trend or general pattern of the other observations in the data when we looked at the scatter diagram. We next deleted that point to compare both with and without the linear regression line to see if it significantly influenced the linear regression and the correlation coefficient. Because it did, it was an influential point.